What's up, guys, and welcome back for another lesson in geometry. Now this one's kind of different because we're going to look at scale drawing. So when you're designing any kind of structure, architects make like a detailed design of the rooms, the building, the landscape. We call these blueprints, and blueprints are a really good example of a scale drawing. The scale drawing helps the builder determine where to put different things. And again, obviously it's not the same size as the building, but it should be in the same dimensions as the building. So I have a little guest here. Also, we're on page 423, by the way. I have a guest here. Come here. Come on. Up. Here. Who wants to say hi? I know you guys are requesting that she be in the videos. So this is Harley. Say hi, Harley. Say hi. There she is. I gotta give her treats to get her to stay in the recording. Okay, look. Right there. Oh, look at that. There she is. Oh. Oh. There you go. So there is her appearance for you guys today. Oh, gross. Now I have her slobber all over. Ew. Oh no, what did I do? Gross. Okay. Anyway, but scale drawings or scale models are used to represent objects that are too large or too small to be drawn or built at actual size. So we're going to look at some views of the Eiffel Tower. Here is a scale drawing of the Eiffel Tower. Here's a scale model. So a model is actually 3D representation. And then this is obviously what it looks like in real life. Now, we're going to use scale drawings to find lengths of actual objects. A lot of times we use scales on things like maps. So the scale gives the ratio that compares the measurements of the drawing. Oh, look at that! Look at here. Up. Oh, there she was. Did you see that? She's such a good dog. The scale gives the ratio that compares the measurements of the drawing or model to the measurements of the real objects. The measurements on the drawing are proportional to the measurements of the objects. So here's an example of a scale drawing, and we can use it to find the actual distance, like on a map. So in a map, you'll see a scale. It says down here that 1 inch is equal to 500 feet. So 1 inch on the map equals 500 feet in real life. So if we want to find, say, the distance between Bowman Road and, or the distance on Bowman Road from Morehart to, what is this? Blair Road. So I want to find this distance right here. Well, we can measure this with like a ruler and estimate that the distance is about 800 feet. So let's see here. Now we can zoom in here and then the scale changes as well. So we're going to look at a few examples, and this is on page 424. So go to page 424. And here is a map of Maryland. Fun fact, I was born in Maryland. Just lived there until I was maybe less than a year old and then moved. But this is my birth state. So we want to find the distance between Hagerstown and Annapolis. And the distance between the two cities on the map is 4 units. So every 1 unit, we don't know what the unit exactly is, but this distance on the map is equal to 24 miles in real life. And so from Hagerstown to Annapolis, there's 4 of these units. If we were to draw a straight line, then there would be 4 of these units on that. So what we're going to do to set this up is set up kind of a proportion here. Every 1 unit on the map is 24 miles. So for 4 units, how many miles is that? This keeps going away here. So now when we write out the proportion, one way we can solve this is because 1 times 4 gives us the 4 units, so we can do 24 times 4 to find how many miles there are here. So there are 96 miles between those two cities there. Alright, so you guys try on the map on page 425, see if you guys can set up that proportion and figure out what the distance is between Akron and Cleveland on that map. Here's another example, if you need another one. So 1 unit here represents or equals 20 miles. So if there's 4 units between Clarksville and 1 unit is 20 miles. So 4 units is how many miles? Well, 1 times 4 is 4. So 20 times 4 is 80 miles. So the distance between those two cities in real life would be 80 miles. You can Google Maps it and see if they're accurate with these. Alright, the other thing you're going to have to do is create scale drawings. Now we're not covering everything in this section, just the first 2 examples, so this is all you'll need to know, but scale drawings, you're going to know how to kind of create your own. So watch this video.
Scale drawings. Designers use scale drawings when designing the layout of a room. To create a scale drawing of your bedroom, first measure its length and width, and then measure the lengths and widths of the items in your room. Make a table and fill in the measurements for the items in your room. Choose a scale for the drawing. For this project, make each 1/2 foot equal to 1 unit. Add another column to the table for the dimensions of each item in the scale drawing. Convert each measurement by using the scale. The scale for the drawing is 1/2 foot equals 1 unit, so 1 foot equals 2 units. Complete the table by filling in the new measurements. On grid paper, use a straight edge to outline the room using 1 square per unit. Choose a location for the bed. Draw the bed using 1 square per unit. Then choose a location for the dresser. Draw the dresser using 1 square per unit. This process can be used to make a scale drawing.
Okay, so that's one way you can make a scale drawing. Now go to page 426 and we're going to look at the example there. We can use scale drawings to find area of real objects. So first we're going to write an equation to set up our equivalent ratios to find the actual length and width of the space, and then we'll use the area formula to find the area. So here is the map of a restaurant drawn to scale, and for every 1 inch on the drawing, that's 5 feet of the actual length of the restaurant. What is the actual area of the kitchen? So on the drawing, it's 5 inches by 9 inches, which would be 45 square inches, but obviously we know that that's not the actual length. So first we want to find the length and width of the kitchen. So if 1 inch is 5 feet, then 9 inches is how many feet? Well, 1 times 9 gives us 9, so 5 times 9 is 45. So the kitchen is 45 feet long. And then the width, if 1 inch is 5 feet, then 5 inches would be 25 feet. So we just have to multiply each of these by 5, and we get 25 feet by 45 feet, which the area then would be 1,125 feet, because area equals length times width. So 1,125 square feet. So let's look at an example and do another one together here. If I want to find the the area of bedroom 3 here, 1 inch is equal to 3 feet. So let's look at bedroom 3. Bedroom 3 is right here, and it's 3 inches by 4.5 inches. Well, 1 inch is 3 feet. So let's find the length of the bedroom. If 1 inch is 3 feet, then 4.5 inches, we'll just multiply that by 3 to get 13.5 feet for the length. Now we have to find the width. If the width is 3 inches, 3 times 3 gives us 9 feet for the width. And now that we have the length and the width, 13.5 times 9 is, anyone got it? 121.5 square feet. Yeah, so that's really all you have to do. Find the actual length and width, and then multiply those together. And that's really as far as we are going to go in this section. So we're not going to worry about reproducing scale drawings or anything like that, but you should just understand the basic concept of what a scale drawing is. Okay, and for one last appearance, come here, Harley. Come on, look, right here. Look, say goodnight. Say goodbye. Look, right here. Oh, there she is, right here. Oh, okay, she's done. All right. You guys, have a good night, or whenever you watch this. Good afternoon, good morning, whatever it is. And don't forget to get a parent to sign. Parent signature on page 427.